Hello guys, this is Jitenjan, and in this lecture again we are going to solve the few problems of GATE 2017 EC branch morning session. Okay, so here in this question, this is from control system, and in this question the open loop transfer function is given gs equal to s plus 1 upon s per p, s plus 2, s plus 3, where p is an integer, and this GS is connected in unity feedback configuration as shown in figure. Given that the steady state error is 0 for unit step input and is 6 for the unit ramp input, the value of the parameter P is, we have to find the value of P. So GS is given, okay, GS is given and the steady state errors are given for the unit step input and unit ramp input. So we need to know the formula for the steady state error for the separate inputs. Okay, we can derive it, but better to remember it. So steady state error for unit step input is 1 upon 1 plus kp, where kp is equal to uh, limit s tends to 0 gs hs, where hs is 1, so only gs. Okay, hs is 1, so put s equal to 0 in gs. So if you put s equal to 0, this will be 2 3 the 6 and 1 by 6, so 1 by 6, but here as power p, so we need to find p. So gs is, this kp is becoming uh, 1 by 6 as power p, but we have to put here 0 at s. Okay, but for that we need to know p. So if it is going to become infinity, sorry, 0 it is, okay, 0, sorry, so steady state error is going to become 0. When it will become 0? When kp becomes infinity. So kp becomes infinity. So when it becomes infinity, when if you put s equal to 0, this p power should be greater than 0. Okay, p should be greater than 0. So, and the next point is ess for the ESS for the unit ramp input, which is 1 by kV, and uh, kV is limit s tends to 0 s into gs for unit feedback system, s into gs. So limit, first you multiply s with gs and then put limit s tends to 0. So it will become limit s tends to 0 s power p, sorry, s power p minus 1 in denominator, and in numerator 1 upon 3 to the 6. Okay, so if you put here as, so it is so this is 1 by ess is 6, so kv is 1 by 6. Okay, so 1 by 6, 1 by 6 getting cancelled, so gets cancelled, so s power p minus 1 equal to 1. It will be equal to, means s power 0, so p minus 1 is equal to 0, so p is equal to 1. Okay, so our answer is 1. Okay, so next problem is three fair cubical dice, okay, are thrown simultaneously. The probability that all three dice have the same number of the up dots on the faces showing up is up to 3 decimal place. Okay, so probability, we need to find probability that all the three dice have the same number of dots on the faces showing up. Okay, so how many cases such cases uh, can occur? So all three dice can have one dot, all three dice can have two dots, like that up to 6. So this is 6 situations. We know that probability of event A occurring is equal to n of number of types, so that event can occur, divided by total sample space, na upon ns. So na is 6 here, because like all three dice can have one dots, all three dice can have two dots simultaneously, like that. So 6 upon, and total how many combination can occur, so 6 into 6 into 6. Okay, so it will become 1 by 36. And if you solve through virtual calci, by virtual with virtual calci, then you will get 1 by 36 as a 0.02 28. Okay, so next problem is it is from the signal system. A periodic signal xt has a trigonometric Fourier series x, okay, xt equal to a naught plus summation n equal to 1 to infinity a n cos n omega naught t plus bn sin n omega naught t. So here it is given x of t equal to minus x of minus t equal to minus x of t minus pi by omega naught. So we can conclude, means the signal is odd as well as half wave symmetry. Okay, so okay, so uh, so which statement is true for this type of signal, means odd as well as half wave symmetry. Okay, so so I can read all options. Okay, so because this is odd signal, because this is odd signal, that's why all uh, all an will be 0 for, okay, an will be 0 for all n. Okay, because this is odd signal, so an are 0 for all n, an are 0 for all n. So okay, so in this two options a and r 0 for any1, a and r 0 for n odd. So above two options a and b can be correct. Okay, because an is 0 for all n, because of this is uh, even signal, sorry, this is odd signal. Okay, because this is odd signal, so an will be 0 for all n. And this is half wave symmetry, means only odd harmonics will be present. Okay, only odd harmonics, so bn will be 0 for all n even. Okay, so option a is correct. So in half wave symmetry signal, uh, only odd harmonics Fourier series coefficient presents. Okay, okay, so on in this, because this is odd signals, that's why the an terms will be 0 for all n. Okay, if this is odd signal, then it will sorry, if this is even signal, then it will bn will be 0 for all n. Okay, but this is odd signal, that's why an is 0 for all n. So next problem is uh, again from control system. So consider a stable system with transfer function this gs equal to s power p plus b1 s power p minus 1 up to bp upon s power q a1 s power q minus 1 up to aq, where b1 up to bp and a1 to aq are real valued constants. The slope of the Bode log magnitude curve of GS converges to minus 60 dB per decade as omega tends to infinity. So a possible pair of values of for P and Q we need to find. So here the key point is GS converges to minus 60 dB per decade as omega tends to infinity. So what does it mean? That so slope is negative means definitely the number of poles are more, means q is more than p. How much it is, how much it how more it is, so q minus p is equal to the slope at okay, so q minus p, because it is a slope, q is more means poles is more, so 20 uh, okay, yes, so 20 times q minus p, and this because q, okay, q is more means minus, put minus because for more poles give negative slope, is minus 60 dB. So q minus p will be equal to 3, so q minus p is 3. So okay, means take difference, 7 minus 1 6, so this is not the correct answer. 5 minus 3 2, 3 minus 2 1, 3 minus 0 3, so only option A is correct. Okay, okay, so next problem is uh, okay, next problem I'll solve in next lecture. Okay, okay, thank you.